I rebuilt the engine in my Celica and I introduced a problem with the air idle control valve. Rebuild went great, except for afterwards my idle has been unpredictable and inconsistent. And what happened was I took the air idle control valve off to replace the gasket. It needed to be replaced. There was a small leak around here. You can see where some corrosion was, and I think that was a source of a small coolant leak. So I didn't take the motor part of it off of there, and all I did was I sprayed it to try and clean it out. And what it is, I created a problem, and I made it sticky. This bearing on the end isn't sealed. So I took this off today to fix it because I knew that was the source of the problem. And first off, it wasn't closed all the way because it was stuck. And then I connected it to a PWM generator, which I'll show a little bit later, and that to control it, and it was sticking. So I sprayed it with some lube and kind of got it working, but I was like, I got to take this apart and really clean it. And I'm glad that I did, because what happened was, so I put some B12 chem tool in here, and it just all leaks right out of the bearing. So this bearing is not sealed. So when I sprayed that to clean it, I sprayed gunk down into the bearing and it was all sticky. So I cleaned it and blew it out with the air gun, and it was still kind of sticky. So I cleaned it again, and then now it moves freely without being lubricated. I'm going to lubricate it before I put it back in there. There's another bearing down there too. So I've got to put this thing up on end and then let it soak in. So that was the problem that I created. I got this off. These normally have that 5-pointed screw on there to keep you from getting in there. And the best way to get one of those off, and one of these as well, is just to drill the top. It's already got it centered there for you. Start with a small drill bit so that it's centered. The shaft on this is 4 millimeters, so don't go any more than 4 millimeters. And I used a left-handed bit, and one of them came out from that, and the other one I got down and then just took the top of it off, and then the stud that was left just unscrewed really easy. So I'm going to lube this up, put it back into my car. Actually, I'm going to lube this up, put it back together, and then I'm going to demonstrate how to test one of these using a pulse width modulator. The air idle control valve operates by the ECU providing it a square wave signal, and the amount is open is dependent on the percentage of the time that it's on, which is called duty cycle. So if you turn the key to the on position before the vehicle even starts, it goes to 75% duty cycle. The way this wiring on here is that this is a negative all the time, and this is positive all the time, and this one here is the signal from the ECM, and that's right next to this piece of plastic. That's the signal wire. So you turn it on, and you'll see the valve inside there open up to a certain amount, and if you lower the duty cycle, it will slowly close the valve. When I first tested this, it was sticking, and it would take like a big difference for it to want to move, because I gunked up the bearings trying to clean it. And so if you go all the way down, my observation is that at about 25% is when it's actually closed and it starts to open up. 86% is fully open, and then if you hit 99%, it snaps shut. So that's how some people are testing it, just to see if it works, but you're giving it full power, and if it's an intermittent problem and not always sticky, it's less likely to show when you're giving it full power. Whereas if you're just moving this thing, you should be able to watch it move smoothly as the duty cycle is going down. And it's interesting because I heard the humming when I would turn my engine on, and it was this. I don't know if you've ever heard humming, because it's getting that square wave signal. So this generates it's called pulse width modulator, so it generates a square wave. And you select the frequency. When I looked at the oscilloscope of the signal from the ECM, it's at 75% when you turn on your car, and the frequency was always 245. So this is a way that you can test the valve. I happen to have this because I use it for testing and calibrating speedometers in an older Toyota truck, like a Hilux type truck. This pulses negative, and that's what this requires. There are different units out there that pulse positive, and it wouldn't work for this, because some things require negative, some things require positive, and these PWM generators, I've had a couple different ones, and they're usually negative or positive. And so since the ECM is providing negative pulsing, this will work. There's a different one that I had before that wouldn't work because it pulsed positive, but it just comes down to the device. Properly cleaning my air idle control valve resolved all my idling issues. Turning on the air conditioning idles it up just a little bit. When I start it up, it doesn't want to stall. All's well. The takeaway from this is no more half measures. If you clean it, you need to completely disassemble it to clean it. That bearing isn't sealed, so you're just going to be flushing stuff down in there. I created the problem. So what you need to do is drill those screws out and then replace them. Flush it all out, and then the other thing is, by disassembling it, you can spin it around. You can really feel and hear how clean that it is, and that's something that you can't do with it assembled. The pulse width modulator does help with testing. It's a better test than full voltage. You can make sure that it moves smoothly and it's not sticking, because that's what was happening with mine, was that if the computer was sending in a signal to do a big difference, it might move, but if it was just doing a small amount, it wasn't going to move it at all. The other thing is that all that thing needs to run it is one of these Walwarts 1 amp 12 volts was enough to operate the valve. So if you are having problems with your idle, the first thing I'd recommend is cleaning it properly, and don't buy aftermarket. And then you'll need the screws, which are 2 M4 20 millimeter long for the motor, or it's like a rotating solenoid more than a motor. There are 3 screws that hold the valve onto the throttle body. Those have a Phillips look-alike head. They're a JIS specification. I didn't have any problems with mine, so I just put them back in. If you do need replacements for them, they're M5 20 millimeter. So both of the screws are 20 millimeter. One of them is 5 millimeter. The other one is 4. There's an O-ring in there. The O-ring didn't look bad. I put it back in because I didn't have anything close to it. If you want to change the O-ring, I measured it, and this is the size. You don't want one that's a whole lot thicker than that, because if it's thicker, it's going to push the electromagnetic part of the valve further out. So you don't want a real thick one in there. There actually is space for a larger or smaller diameter. There's kind of a big gap in there where that O-ring goes. So I just don't think you want a real thick one on there. And that is all. Like, share, and subscribe.